Welcome back. Welcome back. Yeah, we are still busy with the PLC. We are still busy with the PLC now. Remember to like, subscribe if you're not part of the family yet, and also please tell us on the comment section where you watching us from. We'd like to know how far we getting. Want to know how far we going. Now, we were looking at the PLC, and so far we've looked at the basic toggle switch, how to program a stop-start sequence that is basically using a basic toggle switch, and then we looked at how to latch. But I think probably we jumped the gun. Probably we should have explained a very primitive basic concept. The concept of normally open and normally closed. What is this normally open and normally closed? Let's remember again, we can come and open our, look for the icon, there's the WPLSoft. You can, obviously we can either have it pinned to the start or pinned to the taskbar here. So I'm gonna go with whichever makes you happy. So let's go with anyone. And then there is our program opening. I want to do these things. You see, I want you to be familiarized with this. I want it to be so easy for you. I hope I achieve that, because that is the sole purpose. That is the sole goal. So let's go and say, we want to have. That's a previous program. We want to have a new project. So let's not forget how we get a new project. Let's cancel that and remind people. We either go to File and press on the new, and then it gives us this dialog box, or we come and we click on that icon there and it still gives us the same box. But remember, there's the third option. If you just put your cursor on that, it shows you the other option, which is just saying, you can just say control, hit the control button on your thing. I've got my hand on the control button now, and I just hit the N for new, and you can see those are the three ways that you can open a new project. The comport, I don't normally worry about. I worry about the PLC there. I don't know, I put this behind me. I don't know, the PLC I'm using is that guy there, and I don't know, I don't think it's visible enough. We're going to see it much clearer when we are using the other camera. So this is our SS2. So we go and say we want the SS2. So I'll written on the side there, that is an SS2. As if you can read, which I doubt, there's a Delta, is a DVP PS02. So now we want to name our program. We want to say, what are we doing here? We want to know the difference between what? Difference between a normally open and normally closed. So I'll say normally open, NO for normally open, versus normally closed. Normally closed. This is for contacts. So I will just write there Delta PLC, Delta PLC basics, and I'll say what is the normally open versus the normally closed. I want people to understand what the difference is. See it. I want us to see it on the program. So there it opens our new window, and we can expand that so that it's easy for us to see what's going on. All right, it's now nice and big. So we come and say, we said with F1, if I hit F1 there, okay, you get this symbol normally open, okay, X0 there is the default. You can change it to whatever. Remember, you are limited by the PLC that you are using. Our PLC only goes from X0 up to X7, so we can't have X8 and beyond. So now I could have done that. All I did was double click. I double clicked on the what? On the icon there. I first look at the box, the blue box. I'm putting it where I want the component to go, and then if I come and double click, it will. If I now, let's suppose I chose that I want that to be that before the comment and everything, you see it places it there. But now I could also, we said we could have used a what? An F1, so I could have, being on that position, I could have gone on for the function on my computer, hit the function button, and then hit the F1, and you see it does the same thing. All right, and then you say the third option was to load. Okay, the statement, the instruction list, you say load LD, and then you say what do you want to load? I want to load. Then you say you decide which one you want to load. Our example so far has been x0. So if I say load x0, I could say load x1. I could say load whatever x2 up to x7 with this particular guy. But with the other ones, probably the bigger ones, they will have more inputs. So that is how we would get that x0. The three different ways: either the instruction list using instructions, or double clicking on the what on the icon, or basically typing F1. We have an option, a second option now. Let's go and say, what if we had said, instead of this, delete this, what if we had said F2? And yes, the numbering does not matter. You decide whether, but look at the symbol now. The symbol is a slash across it. It's slashed across with the what? With a diagonal line there, which shows that the path is closed. That is a normally closed symbol. Yes, it could be called anything between what? From x0 to what? To x7 as well. Alright, so now, so our x0 can you see, this is the difference with physical components, with hardwiring. With hardwiring, if a specific pattern is normally closed, there is no way you can then decide it's going to be normally open. All right. So, and vice versa. Now, with the software, I can decide if a specific contact is open or closed. I make that decision. I decide whether it's normally open or normally closed. So this same x0, I can decide, no, I don't want it normally open. I want it normally closed. Previously, we've been dealing with it as normally open. Now we're saying, no, we want it normally closed. So now let's come and say, if we do that, look at the symbol. Previously, it was just two parallel lines there. Now there's a slash across. All right. So this is the difference. So what is the difference? Let's have an output. Let's say we have an output. Output again, I could go and click on F6. I could click F6. Let's do that. If I say function F6, look what happens. If I say function F6, what I do? I said function, where's my, I said F5. Function F6, I seem to, is this F6? Oh, no, F7, no, I missed it. There is F7. If I say function F7 rather, there it gives you remember this dialog box from previously, right? You've seen it before. So this is our output. It could be a physical output, it could be internal outputs. We'll deal with that later. All right. So now we could do that. We could use function the same way we did it for inputs. It's written for you. You can see it right there. It's written for you. So you can see, if I want output coil, I can use F7. If I want inverse logic, I could use what? I could use F11. So everything is written for you. It is so user friendly. Everything is so user friendly. So let's come and see. Now we want an output there. So one option was to what? Was to actually click on what? On the icon. The other was to type what? F7. But the other one is simply to say what? Out. To type out. The instruction list, I can say out. All right. So if I say out, then I have to say what output do I want. In this case, I want Y0. So you can see there are different ways of achieving the same thing. They are different. It's so user friendly. You go with the one that makes you happiest. You can do whatever you feel like. I could do the one way or it one way now and do it a different way later. It depends on your mood. So it's so open. It's so easy. It's so nice. So let's see the difference here. Previously, what I will do, let me rather insert a row here. I want people to be clear about this. Let me put the previous scenario that we already know, which was an open scenario F1 or load or clicking on the icon, whichever makes you happy. I will go with function F1. Now you can see the same x0. I say, and there's nothing wrong. I can have the same what? The same x0 on the one line being open, on the other line being closed. That is so beautiful. That is so beautiful. Now, with a physical switch, it is possible to have the same switch having some lines open, some lines closed. Yes, it is possible. With switches, it's also possible. But with software, it's so easy. It's much easier to understand. Now, if you look at this now, I can't have two instructions driving the same output. So if I decided that this is F1, this is Y, remember output them. If I say that this is Y0, It means for the other one here, the output has to be something different to avoid conflicts. All right. If you didn't do that, there'd be a conflict. Let's suppose we remember us and you just said, okay, out, and you said Y0. Okay. Let's say we were sleeping. We didn't see that we gave the same outputs. Let's try and debug this. Let's simulate. Debug. Okay. Now, you've got two different instructions that are saying something must happen here. So as you can see, this is energized. That line is complete. This should be on, all right, but it is not on. All right. So now, I would say my debugging here is failing me with this PLC. With other PLCs, it would have told you no way. All right. But then with this guy here, he seems to not tell us that something's wrong. Because now, you see now, this is not supposed to be. With other PLCs, with this PLC, apparently we can get away with it. I think probably it will cause chaos with your program. So other PLCs don't even allow this to happen. You see when you look at other PLCs, they won't even allow. When you debug there, it will tell you, no, sorry, there's a conflict there. All right. So with this one here, we don't get the message. I don't wonder what the debugger does here, because it doesn't do its usual job. All right. It should tell you, how can you say to someone, jump and sit down at the same time? I mean, really, this guy says open and that guy says close, and then you are instructing the same component or machine. That would be awkward, right? But in any event, some PLCs will not allow you to have different the same output twice. They will not allow you. So we'll see as we go. There are so many PLCs. You will see some PLCs won't allow this. But okay, fine. This one allows it. Let's see the difference here. This instruction here is saying that line should be broken, so there should be no power for Y0. But because a conflicting instruction is saying power to Y0, because it's saying I'm closed here, so it's saying power to Y0, and therefore now you have a situation where even the line that you do normally be off is now energized, because this and that is the same thing. If it gets power and it's the same thing, that one will have power. So you can see already that it does not make sense. All right. But in any event, let's name them different. Let's either change the other one. Let's either change this one here and say output Y1. Try and avoid having things. Other PLCs will never allow it. Try and avoid this situation, because other PLCs will if you get used to this one, you might suffer with the other PLCs. Now let's see. Let's go to the same thing. Debug. And says okay, fine, which is now come out of debug, and let's put it online. All right, now you see what's happening here. All right, with this one, it's on stop, so there's nothing energized, so it's on stop. So it's on stop mode. We haven't run yet, but you can see the difference here. The normally open one is not energized. The normally closed one, you can see is green, is saying I'm letting power through. So the normally closed one is already allowing power through. So what do you think now will happen? What do you think will happen when you run this program with Y0 and Y1? It's obvious. Y1 is going to be energized instantly, because that line is closed. The contact here, this X0 contact is normally closed, so meaning that it's allowing power through, and Y0 will remain off. Why? Because X0, that line, that particular normal open contact there is saying no power through here. All right. So let's see. Let's then run. Yes, I want to run, and then it says, like I said, Y1, because the normally closed XO is allowing the power through, Y1 is energized, and the normally open X0 is obviously not allowing anything through, therefore that Y0 is not getting an output. Can you see what's going on now? Now let's energize this one. We are going to say set on. We are going to energize now. When you energize, what happens? You can see that energizing that X0 is the same, even though I didn't do anything here. Even though I didn't do anything to the X0, you can see that by energizing it, because it's the same name, what you do to the one automatically happens to the other one, because it is the same. Okay, so what happens here now is what? Is that because it's energizing and normally open is closing it, so this line is now closed. And energizing and normally closed is opening it, is breaking it. So you can see that line is now broken. So we don't have any more output on what? on Y1, but we have an output on for what? For Y0. So as you can see, that is the main difference between what? Normally open and normally closed. So without energizing, when you set it off in its normal state, the normally open contact does not allow current through, but the normally closed contact allows current through. This is the major difference between normally open and normally closed. It is very essential to understand this, because for the next part that we are going to do, you need to understand this particular concept. All right, then remember to like, remember to subscribe, remember to tell us where you are so we know who we're talking to. Tell us as many times, because for each video we can't keep going to look. You can't keep going back to all the videos to look, so we won't even know who's watching us. All right, and obviously you can't watch all of the stuff. Probably you might already know some stuff, and you won't even need to look at it. So every time you come and visit us, please tell us that I was visiting. Leave your mark. All right, thank you. See you when we deal with the next session. Ciao.